For our final project, we analyzed the Airbnb listings and evictions dataset. We used 3 out of the 4 tables: listings, ratings, and calendar. From listings, we looked at property type, which contains the property type of the listing. From ratings, we are using the review score ratings, which is also known as the overall score. From calendar, we are using the price of each Airbnb listing on June 8th, 2020. We are examining the relationship between price of Airbnb listings in San Francisco on June 8th, 2020, and their overall rating. Our null hypothesis is that there's no correlation between the Airbnb listing prices and their overall ratings. And our alternative hypothesis is that there is a correlation between Airbnb listing prices and their overall ratings. And our prediction is to determine whether a listing's overall rating can be used to predict its price, and we're using a linear regression model for this. Our join table shows us the amount of listings that have an overall rating above 95 and not above 95. This shows us the distribution of the data. Our aggregated table shows us the standard deviation of listing prices that have an overall rating above 95 and not above 95. This shows us the spread of the data. We can also see that predicting prices with a linear regression model will be less accurate for listings with an overall rating of above 95 as the standard deviation is greater. We created a scatter plot for the overall rating versus the price for each listing we are examining. We can see that these variables have a weak linear association, and it is unlikely that we can predict prices with the rating. The bar graph shows the number of each property type of the listings we are using. There are far more of certain property types than others, and since we don't have access to the population to compare the proportions, we address this by bootstrapping in our hypothesis test.
Okay, so this is the hypothesis testing section. And just to restate our null hypothesis, there's no correlation between Airbnb listing prices and their overall ratings. We chose correlation as our test statistic, and we used bootstrapping in order to reduce biases of the given data set by simulating a range of correlations that could include the parameter. And we used a 1% significance level. So from this test, you can see that the 99% confidence interval is from 0.108 to 0.195. And because 0 or no correlation is not in between these two numbers, we reject the null hypothesis. So next slide. So for the prediction section, we wanted to see if an Airbnb listings overall rating can be used to predict its price. And we chose a linear regression model because prior to this project, we had expected these variables to have a strong positive correlation. Now, based on what we've seen, they actually have a weak positive correlation. So as you can see in the first plot, you can see how the data or the actual points are kind of spread out from the prediction. And to quantify it, you can see the residual graph on the right, as well as the root mean squared error of 150.459. And it kind of shows that there's a relatively large gap between predictions and actual points. Next slide. So in conclusion, from the hypothesis test, we were able to reject the null hypothesis. And from the prediction procedure, we found that overall ratings of Airbnb listings in San Francisco on June 8th are poor predictors of listing prices. We cannot extend our findings to pre-pandemic and post-pandemic because the Airbnb listing prices we used were from a day during the pandemic, which could have impacted the relationship between the two variables. And finally, another analysis we would like to do is to incorporate pre-pandemic data before March 2020 with pandemic data after March 2020 to identify Airbnb price trends in San Francisco.